Hello everyone, today we're going to be talking about enzymes and the energy of enzymes. So the lab is dropping yeast or sodium alginate solution into CaCl2 to form spheres of yeast. So you can form it like as you can see right now, and then it drops into the CaCl2, the solution of it. And on the bottom it should form little spheres or balls of just yeast, as you can see at the bottom of this beaker. So yeah, we're gonna go through this lab and I'll explain it, the reactions and why they happen. Alright? So the enzyme in this case is the peroxidase. Then the substrate is the hydrogen peroxide, and the products is oxygen gas and water. Substrate is the thing that reacts with the enzyme. The product is what you get after the reaction with the substrate and the enzyme. And you have to remember that the active site is where the space between the substrate and the enzyme is. And the enzyme can only react if there's no inhibitors on it. An inhibitor does not allow for the enzyme to do anything. It is blocked off. Okay? So here's just a video of me dropping it in for the camera. This is not a recorded result, so it wasn't very important. And as you can see, in the 50 milliliters of hydrogen peroxide, it quickly goes on. So here's the slow motion. So as you can see, it is slowly going down, and it hits the ground, and it's sitting there, and it's reacting the peroxidase with the hydrogen peroxide, the peroxide to be exact, and it's creating your oxygen, and the oxygen is going to start having a buoyant force, and that's going to be pushing the yeast spheres up out of the graduated cylinder. And as you can see, there are some bubbles of oxygen right there, as you can see following it. Here's another slow motion. I believe that other slow motion was the 0.6% hydrogen peroxide, and then this was cut out, so I don't remember which one it was. It was probably actually the same thing, but as you can see, there are the bubbles going up and along, and some are attached to the ball of yeast, kind of like what happens if you leave your cup out, and oxygen bubbles will bind to the side. So as you can see, it's slowly going up to the 30 milliliter mark. All these tests were conducted with 30 milliliters of the reactant or product, the substrate really. So up at the 40, and it slowly accelerates, but not by much, and you can see little bits of bubbles. And there you go, it's at the top. And here's a picture of, you can see all the oxygen bubbles surrounding the sphere. You can see some below pushing up on it and some attached to it. And obviously there's some that just go straight up and do not help the enzyme go up at all. And in this experiment or lab, I continued to do the results 5 times, and I got the averages. So the concentrations in the substrate and the substrate type I had, and the time it took. So water average, it never came up, and it really shouldn't, because there aren't any enzymes for the substrate to react with to create the oxygen to give it the buoyant force. And so the average, like the control average for the 0.3, so that was kind of like the control for the hydrogen peroxide, and that had a average time out of 5 times of 11 seconds, 11.538 seconds. And then the 0.6 hydrogen peroxide average is 8.368 seconds, so much faster. And then the 0.15, so half of the control, is 59.172 seconds, which is quite long. It felt like it was never going to go up, but it did slowly react and eventually came out. So as you can see, the chart, with the larger amount, the more time it took, except for with the water average. The water never rose. Well, and it shouldn't, theoretically. Okay, so now I'm going to talk about the reasons why we had the faster and the slower. So, for example, what conditions resulted in maximum levels of enzyme activity, or creating the most products at the faster rate? The concentrations that resulted in the maximum levels of enzyme activity is a higher concentration of the substrate, and the substrate in this case is hydrogen peroxide. And with the higher percentage of hydrogen peroxide means a higher amount of enzyme activity. A higher amount of enzymes from RMM, or random molecular movement, which move the molecules around, and more molecules to randomly hit the enzymes. That means more reactions and faster reactions due to there being more molecules. That means that there are more molecules of peroxide, hydrogen peroxide that is, for the peroxidase to react and have a product of O2 molecules. The oxygen molecules are a gas, and oxygen gas is much less dense than water at room temperature. Kind of like how lead is quite dense, but it's not as dense as mercury, that's why it floats. Okay? And so the oxygen molecules are a gas, and oxygen gas is much less dense than water at room temperature. And being less dense, you have a buoyant force of the gas, and which effectively pushes up the yeast, making it float to the top. And you can see that in the change of data. But what about the slower? Well, the conditions that resulted in the minimum levels of enzyme activity is a higher concentration of... So, a lower amount of enzymes activity from RMM, which move the molecules around, and with less molecules to randomly hit the enzymes. This means less reactions and slower reactions due to less molecules. So it's effectively the exact opposite, except for the yeast spheres eventually do get to the top as long as there's enough enzymes to give it enough force. Okay, that's been my data. Thank you guys for watching. Have a nice day.